In lesson 3, we are going to be talking about climate changes and patterns. So, our climate is in a constant state of change, but human impact seems to be causing climate to change faster than ever observed before. And the question is kind of, do we do anything about this and what can we do about this? It's interesting to note here, and here's a cool picture of the ice ages. And just one interesting note is that while the ice ages ended 10,000 years ago, it was actually only about an average of 5 degrees cooler than what it is right now. So we will talk about how much temperature is changing now and what if anything we can do about it. So different climate patterns happen for different reasons. So when our northern hemisphere is tilted away from the sun, we will have our winter. And normally this happens in November, December, January, February, when we start to have our winter. Right now, we're in a phase in like fall spring when we are don't really have much of a tilt. The tilt's always like increasing or decreasing as you go along, but right now we're pretty close to straight up and down in the spring and the fall with our directionality and facing the sun. And I wish that it would have shown one more picture. I'm not sure why it left it off. It's a little frustrating, but when our northern hemisphere is facing the sun, that's when we have our summer. Well, the opposite is true for the southern hemisphere. While we are here in the shadows and having our winter in December, the southern hemisphere is more facing the sun and they are having their summer. And then we get to a time period where it's kind of not quite equinox. It can be where it's everything is equal, but you'll have spring and summer where most of the earth is getting about the same level of sun. And then we will have our summer where we're tilted into the sun and the southern hemisphere is tilted away and they will be having their winter. So this is how we get our seasons. So that's one climate pattern is the seasons. It's fairly predictable. The next thing, and I have a great video about this on Canvas, so I hope you just watch this and learn about El Nino. But I will briefly explain it here. Basically, our normal pattern for water movement is that very cold polar waters will come up and meet here and head out towards Australia. And as they head out there, the trade winds and currents will move it along. It actually will warm up quite a bit. Because now it's along the more towards the equator. It's not in the polar regions anymore, so that water will heat up and then get to Australia where it'll be very warm. And they have a lot of shallow areas here where it can really get warm. An El Nino year is when there are not very good trade winds and there's a strong countercurrent that's going back this way. And the warm Australian waters come towards us. These warmer waters are obviously nice for us to swim in, but they do kill off our kelp. And because without our kelp, which is like a very important species, for our kelp can only live in very cold water, which is why in the summer you see a ton of it dead up on the beach and covered in flies because it was too warm of water and it all died off. In the winter, the beaches are fairly clear when the water is cold because our kelp is meant for very cold water. So when these currents come in, we'll have a huge kelp die off, not very many fish in those years. We will get more rain for our El Nino, which is great for us. And what it also means is it puts Australia in a drought. So us getting our El Nino means that Australia will go into a drought. And then in the video, it also talks about La Nina, and you can look at that video and see great animations of that. So There's natural causes for climate change, and these are that the Earth's orbit changes. I will sit here and go to the orbit picture. And then the Earth's tilt will change. The Earth's wobble will affect climate. There are different feedback loop patterns that affect climate, and also volcanic activity affects climate quite a bit. So these are all natural causes of climate change. So Earth's orbit is not always sometimes it's more circular. I know this is still not a circle in the red. And then sometimes it's more elliptical. And this changes over time. About every 100,000 years, it kind of becomes more circular and then more elliptical. This obviously will change climate a little bit. This is very exaggerated, by the way. This picture is very exaggerated, but this will change our climate a little bit, but scientists do think a lot less than. And they have some, rock data and things like that. They've looked at fossil evidence and whatever, but they think this a lot less than what human impacts are right now. Additionally, Earth's tilt, like we talked about with the seasons, this can obviously affect climate. And this tilt, I will go to this one here. This tilt actually changes about every 41,000 years, where we are more or less tilted towards the sun. So they expect us to be more straight up and down when this tilt is finished, and then it will go back. But at that point in time, the northern hemisphere will get more, have, hotter summers, cooler winters. That's obviously going to be a long-term climate change that happens there. Then Earth actually wobbles. So right now our North Star is Polaris, and we're about halfway through our 26,000 year cycle. And in about 13,000 years, they expect us to be more pointed towards Vega. So we are going to wobble a little bit. I don't know if I'll be around in 13,000 years to experience that, but the Earth does change, whether it's more straight up and down or more tilted to the side like that. The next one is feedbacks. And feedbacks are really kind of harder to understand. So I want to take a second to explain it. So it brought up this example of albedo. And albedo is, like here in this first picture, has high albedo. This is where, because the ground is covered in a very white reflective snow, it's going to reflect a lot of the light back up and a lot of the sun back up into the atmosphere. And a lot of it will not stay on the ground. That's why when you touch snow, even if it's been in the sun all day, it still doesn't feel very hot. That's why the lighter concrete outside is a lot cooler than the like blacktop in the street, because of that reflection. Okay. So when you have decreased snow and you have decreased like glaciers and snow cap, not only is that snow or glaciers gone, but additionally, the ground underneath that is darker absorbs a lot more heat. And as it absorbs a lot more heat, it tends to start melting more snow and glaciers and warming the water, etc. And so it's this loop where the hotter it gets, the more heat it's absorbing, so the more it's melting other stuff, so the hotter it gets and the more it's melting. So that's called a positive feedback loop, where it is amplifying and causing this change to be stronger than it would otherwise be. Then there's also volcanic activity. So I'm going to go to this cool picture of Mount Pinatubo. When it erupted, basically volcanoes release large amounts of dust called aerosols into the air. And these are dust particles and they stay in the air and they block sunlight for a decent amount of time. So they actually found with Mount Pinatubo, Mount Pinatubo, that they had cooler temperatures um, globally. We saw temperature changes after the Mount Pinatubo eruption for a couple of years after it erupted. And they estimate that this large eruption caused the Earth's temperature to decrease by about 2 degrees. So, this is more of a short term climate change. So, some of the things that we've talked about in this section are like long term climate changes. And that would be more like this Earth's wobble or the Earth's tilt, which they show here, or the Earth's axis changes. And then there's other things that are maybe more short term that can be changed. And that's like the feedback loops, and then volcanic eruptions that only last for a few years. All right. Have a great day.